Assalamu alaikum. Thank you for the organizers of the BML 2021. Thank you for this opportunity that let us talk about our work and share our work with the research community. My name is Noureddine and I am a PhD student at the University Hassan II, Faculty Benlahmar of Sciences. Our work our presentation will be entitled Hyperparameter Optimization in NLP Architectures. The supervisor of this work is Professor Benlahmar Habib. So, the layout of our presentation is as follows. We're going to talk about hyperparameter optimization problem in NLP, the HPO techniques that exist, and the objective and method that we followed in our study, the research and discussion, especially the HPO strategies, and we're going to conclude our presentation. So, in the hyperparameter optimization problem, what is this? As data grows in size and complexity, algorithms processing it are getting more complex, especially when dealing with natural language processing in NLP tasks. A major component of this complexity stems from the optimization process of hyperparameters. Deep learning models share a multitude of their models' hyperparameters, but when dealing with a specific task, like in NLP, with specific architectures like RNNs and LSTMs, or more recent transformer-based ones, generalizations cannot be easily made, and the optimization becomes more task-specific. Hyperparameter optimization is mostly done manually or by testing a predefined set of hyperparameters in a grid, or by exploring the search space and randomly selecting the optimal hyperparameters. More sophisticated techniques have made their appearance and were applied to HPO, like the Bayesian optimization and also the evolutionary algorithms, and also other algorithms have made their way in HPO techniques. There are heuristics-inspired algorithms like simulated annealing, particle swarm optimization, and ant colony optimization. In our work, we have inquired into the use of hyperparameter optimization in natural language processing. By investigating a group of papers in the domain, we try to spot the techniques used to optimize these hyperparameters as well as the tools used to tune them. We try also to find any pattern related to the most important and useful hyperparameters and set them apart from the less useful ones. We finally set a list of recommendations regarding the use of hyperparameter optimization in the context of NLP. The studies selected for this paper are the result of research in academic databases based on an adapted search equation. A study selection was applied on the resultant papers, inclusion and exclusion criteria, as well as other criterions. They are highly cited papers in the domain of NLP dealing with hyperparameter optimization and published in highly respected journals and conferences in the domain of artificial intelligence. For our results and the discussion part, the strategy of hyperparameter optimization adopted throughout the research papers depends on the task at hand, the available resources, and the dataset complexity. For example, with dialogue act classification, Bayesian optimization proved to be efficient, but it is very expensive. Thus, performing a multi-stage Bayesian optimization can yield better and faster results. Its variant, the Gaussian process, proves to be faster than the random search in dialogue act classification. When used with simple heuristics, it may not find optimal hyperparameters as well. When dealing with multi-label text classification tasks, the degree of impact of the hyperparameters is not the same, and some have no impact at all on the model. The combination of glove embedding, for example, glove embedding type, sigmoid for the last layer, bi-groove, deep architecture, NADM as optimizer pooling, and some other values these values proved to be very efficient for this type of tasks. In tasks related to linguistic sequence tagging, the combination of the optimizer NADM with a gradient normalization threshold of 1, variational dropout recurrent units of LSTM layer, and the CRF classifier proved to be very efficient. In machine translation tasks and under a transformer architecture, like in the paper Vaswani of 2017, specific hyperparameter values were chosen, namely Adam as optimizer, a learning rate that is variant according to the warm-up steps, which start at 4000, a residual dropout rate of 0.1, and the label smoothing of 0.1 as well. With the task question answering and natural language understanding, the authors in the paper Devlin 2019, they recommended setting dropout probability to 0.1, a batch size to 16 or 32, and epochs to 2, 3, or 4, and a specific value for the learning rate. For our recommendations, we found that not all hyperparameters have the same impact on the models, and the nature of NLP tasks favors parameters like the word embedding type, the dropout rate, the optimizer, which are more impactful than others. And relying on full AutoML, we found also that relying on full AutoML research may be counterproductive as an HPO strategy, since it could be greedy. A simple combination with a manual approach, for example, a plot between promising hyperparameters and validation loss, could produce optimal results. Applying different HPO techniques on NLP models may be time-consuming or expensive for some tasks, especially with big datasets, but their use proves to be effective when the sweet spot of optimal values is reached, especially with the use of pre-trained models, since they are highly effective in the field of NLP, and the tasks also in this domain are recurrent and repetitive and deal with a homogeneous entity, which is language, meaning that the hyperparameters that are optimal in a big model will very likely yield the same results in smaller tasks with the same nature. We found that there are some issues with some issues that tackle a good HPO, a good hyperparameter optimization strategy. These issues are related to starting point of the optimization, like warm start, transfer, learning, and the exploration space and its management, like the hyperparameter size, also the dataset size and the number of iterations at its management, for example early stopping, and the nature of the dataset and the task supervised or not, regression or classification, and also the resources used for the optimization, especially in the context of deep learning. We conclude our work by saying that good practices in hyperparameter optimization is in natural language processing related tasks. We found that there are common traits in the optimization process of hyperparameters, and that some particular HPO techniques work well with certain tasks. Also, the values reported in this paper from certain studies can be reproduced in similar tasks. The recent developments in the transformer architectures have paved the way for optimal models down the line by means of transfer learning that benefits ultimately the hyperparameter optimization in NLP. Thank you very much.